All right, class, welcome back. We are on 10.2 now. 10.2 is another lesson about areas. So, to start, let's write our goal out to find the area of a trapezoid, rhombus, or kite. We're going to start right away with area of a trapezoid. The best way that I can, and I don't have to do this, but I choose to explain why we do the areas because it's easier to remember it. Honestly, when I think of a trapezoid and I think of the area of a trapezoid, if someone were to come up to me and say, hey, what is the area of a trapezoid? I don't think about like recalling it from memory. I think about what a trapezoid is before I can tell them what the area of a trapezoid is. And this is how I do it. Basically, what we're going to do is we're going to say, what if I cut this trapezoid in half? And I'm putting midpoints on both sides. And if I cut it in half like this, if I drew a line there, what would the length of that line be? Well, the answer to that question is, since it's halfway between like the top and the bottom, it's actually the average of base 1, as you can see, B1 on the top and B2 on the bottom. It's actually the average of those two numbers. Think about that a little bit. What the length of the line that I drew on the trapezoid is halfway between the top and the bottom, so it's actually the average of base 1 and base 2. So if we were to say base 1 was 5 and base 2 was 7, the length of this line would be 6. Exactly 6. As long as it was bisecting those. So that's where we got to start. I'm going to erase some of this stuff here so we can continue. So this line that I've drawn is the average of base 1 and base 2. So that's actually got to be a part of our formula. But before I get to the formula, once we have the average, we can actually just multiply it by the height. And look what happens. If we multiply it by the height, if we just do basically the width times the height, look what happens here. I'm going to change over to a highlighter here, make it a little bit smaller so it's easier to draw. This piece right here, I'm going to change colors. It's very important that you watch this. This piece right here will fit perfectly into this little spot right here. Perfectly fits. And then this one, I'll change colors once more. I'm going to maybe have to go a little bit smaller even. This one right here fits perfectly into this spot right there. So, what I'm getting at here is it's a very similar formula to base times height. It's very similar, except our base is really this piece right here, and we said that that was the average of base 1 and base 2. So I've seen a couple of ways of writing this. I've seen this one, base 1 plus base 2 divided by 2, which would be the average, right? Times height. And that's really the one that I use the most. Base 1 plus base 2 divided by 2. But I think the one that they give you on the semester test would look like this, so maybe you should write it as well. Area equals 1/2 height base 1 plus base 2. The reason I use the top one is because it works conceptually for me, and I can kind of see what's going on. The bottom one just seems more memorized, you're going to have to memorize it. So pick whichever one you want, doesn't matter, and that's the one that you're going to probably have to use. Hopefully that made sense. Maybe pause the video and just check for understanding. All right. Now we have another trapezoid, and we have, well, we got to see what we can fill in here. First of all, we need both bases, and base 1 and base 2 are the top and the bottom. Remember, our bases of a trapezoid are parallel. So if we went back up to our original image, I could show that those are parallel. These are parallel as well, and I know that those are my bases because they're parallel. So we have both bases, but we don't have a height yet. Well, where would my height be located? I could, if I know that this is a 90-degree angle, this could be my height over here. But I don't really know how to find that side. So instead, I'm going to have to kind of maybe split this up a little bit the way that I want to split it up. And this is how I'm going to do so. I noticed that we have a 60-degree angle. And you guys on your note guides yesterday wrote down our templates for 30, 60, 90 triangles, so I'm not going to go through those again. But I can make a 30, 60, 90 triangle out of this if I wanted to. If I make a 30, 60, 90 triangle out of this, I need another side. The easiest side to get would be this one down here, which would be 2. And how do I know that it's 2? Because this one and this one have to be the same then, because I made a rectangle there, which would change this to 5 and that one to 2. Hopefully that makes sense. If not, raise your hand, and he can pause the video and talk to you about it. But if we know that's 2, we know our hypotenuse would be 4. But we don't really need the hypotenuse. We really just need this side over here, our altitude, which we know would be perpendicular there. So for my altitude, it would be 2 times the square root of 3. And that is just using 30, 60, 90 triangles, and that's it. So now we've got everything we need. We can fill it in. Base 1, we said was 5. Base 2, we said was 7. Divide that by 2 and multiply it by our height, which is 2 times the square root of 3. And I don't need us to put it in radical form for this. It doesn't ask us anything. It doesn't ask us to do that. So I'm just, well, I could probably put it in radical form. Maybe that would even be better. I don't really know. It's not asking us to, so we could do either one. Area of trapezoid, I'll put trap because I know before we were doing area of T, and that could be a triangle. So maybe you would want to put TRI on the bottom. I'll put TRAP there. If I wanted it in radical form, 5 plus 7 divided by 2 is 6. 6. 6 times 2 is 12 root 3. So this would actually be perfect. If I wanted to change it to a decimal, I believe that is 20.76, rounding to the nearest hundredth. And I'll put it in meters squared. Okay, that's it for that one. If you have questions, again, raise your hand. Moving on to a rhombus. Area of a rhombus. Let's see. I'm trying to figure out how to explain this to you guys while not being there. Well, it might be something I have to explain more in depth when I get back. Area of a rhombus, I just don't want to waste too much of your time when you guys can be working on stuff. The area of a rhombus formula is 1/2 diagonal 1 times diagonal 2. 1/2 diagonal 1 times diagonal 2. Trying to think of the best way of showing you that. We might just have to move on. Let's see here. So basically, these are kind of tricky here to think about, because this arrow is pointing at this line right here, and that 3 is basically talking about this half of the line. So this one would also be 3. This one is 5, and this one over here would also be 5. So this is a pretty easy formula. I just have to plug in area of rhombus equals 1/2. One of my diagonals was 10. The other diagonal was 6. This equals 30 feet squared. Check for understanding here and move on to the next one. It says rhombus WXYZ has an area, so it's giving us the area there. It wants us to find WY if we knew XZ. So XZ is 10, so I can even show you that by putting a 5 there and a 5 there. So that's 10. We know our formula is 1/2 times, and actually I'm going to erase area because we know what the area is. The area was 100. 100 equals 1/2 times one of our diagonals was 10. The other diagonal, we don't know. So basically, 100 equals 5 times x, divide by 5, divide by 5. X equals 20. 20. And I'll put, oh, it does say meters, I guess, in the question. So I'll put meters after that. Check for understanding on that, and we will move on. A rhombus has sides of 10 centimeters long. If the longer diagonal is 16 centimeters, what is the area of the rhombus? I'm going to have to draw my own here. So you can draw yours too. Just remember our properties of rhombi go as follows. You need a couple things. You need all sides to be the same. So 10, 10, 10, and 10. And then all the other sides are, well, sides are parallel with each other. Opposite sides. I don't think we really need that for this problem, though. It says the longer diagonal is 16. That would be the longer diagonal. It wants the area of the rhombus. This is pretty easy. We need the other ones, I guess. So I'm gonna erase the 16 here quick so that I can draw this a little bit better. I'm going to draw my other diagonal. Oops. Like I said, I'm kind of struggling to draw on this. We said it's 16, so I'm actually going to split it so I can see it better. 8 and 8. Our other property of a rhombus is that our diagonals are perpendicular. We talked about that when we went over a rhombi before. These are perpendicular. So I'm actually going to show that by putting a 90-degree marking in there. And basically what we have here, if I were to erase everything, and I'm not going to erase everything, but I'll highlight what I mean. Here's what I'm left with. Look at this. What I'm left with here is a right triangle with two sides, and we're basically trying to find this other side of the triangle. We're trying to figure out what x is. Because if we know what that is, we know that this is the same. And if we know what both of them are, then we can add them up and we'll have our other diagonal. Then we can find the area, which is what the problem's asking. So this is how I'll do that. I'll say my hypotenuse is 10 because that's opposite my right angle, as you can see. So my hypotenuse is 10. One of the sides is 8. And, oops. And I don't know what my other side is, so I'll say a squared plus b squared equals c squared. We have the Pythagorean theorem to find this little x down on the bottom here. So a squared plus b squared, so a squared plus 64 equals 100. Minus 64 minus 64. we get a squared equals 36. Square root both of them. A equals 6. So that means I might not be able to do this. Let's see. Erase those things, and then I can write in 6 and 6. Now the question's asking for the area. So we know that one of our diagonals is 16. Our other diagonal is 12. We multiply those things together and by 1/2. That was our area of a rhombus. 1/2 times 16 times 12 is 96 centimeters squared. And that's our final answer for the rhombus. For a kite. Now, a kite is not a rhombus, but they do have the exact same formula. So this one is also 1/2 diagonal 1, diagonal 2. That makes this pretty easy for us. One thing to remember, that if this is 4, that one also is 4. Remember, on a kite, those two things are congruent. So then that's pretty easy. 8 is one diagonal. 10 is the other diagonal. Multiply those things together and multiply them by 1/2. Area of a kite. And that equals 40 inches squared. And that's it. So this was lesson 10.2. Make sure you check that you understand everything on here before you attempt that worksheet. If you have questions on any of this stuff, these are all on Google Classroom. So you can go on and you can rewatch these as much as you want until you understand them. You guys will have a quiz on Monday. If this is being played at the right time, then this would be played on Thursday. So tomorrow you guys will have an assignment on Math Excel. It'll be a review. And the good thing about that is that you'll know if you're getting the questions right or wrong right away. And that'll be a good review for you guys, because you'll know if you're doing them right or not. And then on Monday, you guys will be taking a quiz just to kind of see if you guys know this stuff. I am not going to give you the formulas for that quiz. Mostly because it's not a test, and if it was a test, I might give you the formulas, but I want you to know the formulas. I don't want you to have to resort to a formula sheet. Just, these are not that difficult. The two that we talked about the first day, lesson 10.1, were just base times height. This one, you have rhombus and kite are the exact same, and they're pretty easy formulas. And then the trapezoid is the one maybe you'll have to work at a little bit, but I want you to actually work at that. And if you use the one that I use, average of the bases times height, that's really not that difficult either. So that's the plan. You'll get a lot of practice with those tomorrow. And then Monday, just don't forget to study over the weekend. Look at the formulas at least over the weekend. Monday, you will be taking a quiz. That is it for now. Good luck with the homework.